Hello, I'm Dr. Chris Burke at the School of Computing at the University of Nebraska-Lincoln. And this is an introduction to get you started in Computer Science 1. We're going to be basically running through your first lab, which gets you set up with all the accounts and all the resources that you're going to be using throughout the semester. Before we begin, you're going to have to set up some accounts. The first one that you're going to want to do is GitHub. So you're going to want to go to github.com, unless you already have a GitHub account. And it's going to look something like this. Just go ahead and sign up. I suggest that you use your school email to do so because you might be entitled to some freebies with any email that ends with a .edu as a student. The second account that you're going to want to claim is your CSE account. If you go to cse.unl.edu/claim, it's going to look something like this. Now, for the vast majority of you, you're going to claim your account using your Huskers email. Some of you may not be in the College of Engineering, in which case you may not have a Huskers email, in which case you'll have to use an alternate email as indicated by your instructor. You can also come back to this website to reset your password if you need to. The next thing you're going to want to do before starting this lab is to familiarize yourself with the course, its resources, policies, and other items. Some of those are enumerated in the lab handout itself. For example, the main School of Computing website, the UNL institutional computing policy, the academic integrity page, and a couple more resources there. Finally, you're going to want to accept the invite that your instructor might have sent you through codepost.io. This is a website in which we'll provide greater feedback on all of your assignments. So now let's go ahead and walk through Lab 1 and get you started. Broadly speaking, we're going to show you how to use an online IDE, an integrated development environment. We're going to show you how to create and edit files. We're going to show you some basic Unix commands. Then we're going to show you how to clone a lab from GitHub, which you'll be doing throughout the semester. Compile and run a program. And then finally submit and grade your program. And then we'll briefly show you what CodePost looks like when you actually get something graded. The IDE that we'll be using is Visual Studio Code, which has been set up for us and is free, courtesy of the CS50 project. This is why you'll need a GitHub account. Go to the URL provided and simply log in via GitHub. When prompted, you'll have to log in using your GitHub credentials. Once you do so, the IDE should look something like this. So first of all, observe the layout. We have a file explorer over here on the left. We have a terminal down below. And then we have our text editor area. Now before we start, we're going to have to set some things up specifically for this course. So I've already provided some of the commands to set things up properly for you in the handout, but just to run through those really quick. First of all, we're going to make a directory. Now you can make directories by right-clicking over here in the File Explorer and going New Folder, or New File if you want to. Or you can do that down here at the terminal, using Unix commands. mkdir is short for Make Directory. Then you give the directory a name. We're going to make a couple of directories under the Workspaces directory that we're in. So if you type mkdir under the Workspaces directory, we're going to make a directory called CS1. Now, as you can see, I've already done that up here. That's why I've got this CS1 directory already existing. But once you hit enter, it'll make the directory for you. We're going to make several other directories to hold our labs, our hacks, and a miscellaneous directory so that we can play around with it. So, mkdir/workspaces/cs1/labs. That'll create a lab directory under that CS1 directory that we created. We'll also mkdir workspaces cs1/hacks and miscellaneous. Now you'll note here you're not getting any feedback because that's the way that Unix works. No news is good news. If there were an error, it would actually tell us about it. But since there was no error, it simply just goes on to the command line and we can enter in another command. Next, we're going to set up what's called a symbolic link, typing ln-s, ln space -s, workspaces, cs1, cs1. Now, I've already done this, which is why I've got the cs1 already up here. But we're going to have to do this for various reasons. If you're interested in them, read the handout. Now, if it was successful, you can expand that CS1 folder and see the subfolders that you just created: hacks, labs, and miscellaneous. I've got some other stuff in here from other projects that you may not necessarily have. Now, how do we get files into our IDE to start working with them? One way that we can do that is by right-clicking and creating a new file. I'm going to go ahead and create a file called info.md. This is a markdown file. MD stands for markdown. It's just a plain text file that you can start typing stuff into. You can get access to this file by double-clicking on it, and it'll open it up in your IDE, and you can start typing. As you edit each file, it's generally automatically saved. You can delete files by simply right-clicking and selecting delete. Let me go ahead and recreate that file so we actually have something to work with. Now, when you first come into the IDE, you're going to be in a directory that is not inside the directories that you created, so you're going to have to move into those directories. Each time you come in, that simply means that you're going to have to go cd cs1. Remember that all file names are case sensitive, and you should avoid white space in your file names and directory names. CD is short for change directory, and so we're changing the current working directory into the CS1 directory. Now we can type ls, which is short for list. And you can see all of the files and directories that are under this directory. Let's go ahead and change directories into that miscellaneous directory that we just created this info file. cd misc. If you type ls again, you can see that the file info.md is being listed. That's the only one in this directory. Now you can go back up one level by going cd space period. And we're back at the CS1 directory. This is a hierarchical file system. So you have a root, and then you can go down into subdirectories. Let's go back into the miscellaneous directory. Now, sometimes you might get lost, in which case you can find out where am I, what is my current directory, by typing pwd. And there's the full directory that you're in. You're actually in workspaces, and then you're inside a folder that corresponds to your GitHub ID. And then we're in a subfolder called CS1, and then a subfolder called miscellaneous. Folders and directories, those terms can be used interchangeably. Now you can remove a file by simply right-clicking and deleting it, or you can do it from the command line by saying rm, whatever file name that you want, info.md in this case. rm is short for remove. Be careful. Once you've removed a file, that's it. There's no undelete. It'll even ask you, do you actually want to remove this? Hit yes, and now that file is gone. It's still being displayed up here. That's just because we haven't refreshed our file explorer. Anytime that you need to, you can go ahead and refresh it by clicking this little icon here. And you'll see that there's no longer any file in the miscellaneous directory. It's still open over here in our text editor, but we can go ahead and close that. Be careful with deleting files. Again, there is no undelete. Now let's go ahead and actually get started coding. First of all, I'm going to create a source file called hello.c. Remember, file names are case sensitive. So if you name your file something else, which is perfectly fine, you will have to be mindful of the commands that you run. Now I'm going to go ahead and cut and paste some code that we provided in the handout. This is a basic Hello World program. I'm going to go ahead and put my name as the author though. I'll go ahead and leave the date. but you should update the date to the current date that you're working on. Now, don't worry about any of the code yet. We haven't really talked about any code, but we are going to show you the process of editing this code, compiling this code, and then running this code. Be sure to save the file if it's not automatically saved. I am in the miscellaneous directory. If I type ls, I'll see this hello.c file. And now I need to compile it. The compiler that we'll be using throughout the semester is GCC. GCC, and then the file name that you want to compile, in this case, hello.c. And if there were no syntax errors in your program, again, it should not report any problems. If there were syntax errors, then it would report the errors or warnings. But no news in Unix is good news. Everything worked. In fact, if we go up here to our File Explorer and refresh, we'll see this brand new file called a.out. That's our executable file that we can actually run now and see Hello World being printed to the screen. To run it, go to the terminal and type /a.out. And then followed by enter or return. You can see here that it's going to print Hello World. That means that we successfully edited a program, compiled it, and ran it in our IDE here. Next, let's make a change. Instead of greeting the world, I'll greet myself. Hello, Chris. Now, if I just go down here and run it again, right, I didn't recompile, so I should not expect new results. Even though I changed the file and saved it, this file a.out was not changed. That's all right. We can go ahead and compile it again, gcc hello.c, and hit enter. And now, if I run it again, I'll see the different message. Here's a quick tip. You notice that I didn't retype any of that. I just hit up, and I can scroll through all previous commands that I've run on this IDE before. You can also press down to scroll through the other way. You can also use command completion. So I didn't have to type out hello.c the entire thing. If I just go gcc space and then a partial file name, h, and hit tab, it'll complete it for me. Okay, so that's some of the basics. Let's go ahead and actually start on this lab. I'm going to go ahead and go back one level directory up, and then I want to go down into the labs directory that I created previously. So I'll go cd space period to go up one level. Remember that takes me back to the CS1 directory that I created. And now let's go down into the labs folder, cd space labs. And you can see that I'm now in the labs folder. I can go ahead and collapse this miscellaneous, expand labs, and see that still there's nothing in there. Throughout the semester, you're going to be cloning some starter code from GitHub. If you type git clone and then the URL for lab 1, you can either type it out or you can cut and paste it. And then hit enter. What that's going to do is it's going to go out to that repository, grab all the starter code that we've provided, and make a local copy. If you go up to the File Explorer and hit refresh, you'll see that there's this brand new directory. If you go down to the terminal and type ls, you'll see that there's a new directory containing all the repo code that you just cloned. Let's go ahead and change directories into that new directory. Again, you can use tab to complete and not have to type out the entire directory name. You can type ls and see that there are a bunch of files in here, including a hello.c file, a directory of images, and then the readme file that you should be following along with, as this is the walkthrough for that. Let's go ahead and open up the hello.c file. It's going to be very similar to the hello world file that we just played around with. But you're going to want to change the author name, include your email, and today's date. A description of the program has already been provided for you. This entire thing is what's called a header. It's kind of like putting a header on your English essay to indicate who wrote this. Now let's go down to the actual code. Instead of printing out hello world, Let's change it so that we're printing out our name and major. That's the message that will now be displayed. Don't worry about the details of this code yet. Again, we're not there yet. If you want to print out another line, you can go ahead and copy and paste the printf statement and change it to your partner. And her major. Now, since I'm already in that directory, I can go ahead and compile as before. gcc hello.c. I can run as before. If I refresh this, you'll see that an a.out file has been created. And I can see the message printed on 2 lines now. But how do we get a file that's on the CS50 IDE over to this system? Well, first of all, we have to bring it down to our computer. Because this exists on GitHub servers or Microsoft servers or whatever it is, we need to get it a copy to our local computer here. To do that, you can go ahead and right-click any file and select Download. I now have a hello.c file here in my download directory. Alright, so now let's hand this in. You'll see here that I've already got the program. It's been updated to include the I love the School of Computing text that's required by the updated labs. And we're going to be using a program called CodePost to hand this in and grade it. All you need to do is point your browser to codepost.io. You should have already gotten an invite or a link from your instructor. You will log in using the email address that is associated with your Canvas login. And when you come in, it should look something like this. This is lab 1, so I'm going to go ahead and upload the assignment. You'll see here that the file that is required is hello.c. You may be able to hand in other files, but they will be ignored. You will not be able to grade or submit until you handed in all the files. Navigate to where you downloaded the hello.c file from your IDE. Select it, and then click Submit and Run Tests. Once it's up, you'll see a message that looks like this. This does not mean that you're done. This does not mean that your program is correct. What you need to do is you need to click View Test Results first. This will tell you how many test results passed, how many failed, and the points that you've earned for either passing or failing those tests. So you'll have a message here with an explanation of what that test is doing. You can go ahead and take a look at any additional logs that may have been posted. Now, because my program was correct, this is going to go ahead and pass and give me my 15 points. Let me show you what it looks like if it doesn't pass. I'll come over here and I will put in I like the School of Computing instead of love. All right. Now let's come over here and re-upload the assignment. You can go ahead and upload and re-upload as many times as you want up until the due date. So let's go ahead and resubmit this. And again, I'm getting this message that just tells me that the upload was complete and successful. You still need to click on View Test Results. And you'll see here that that test has now failed. Why did it fail? Because it should have printed out, I love the School of Computing instead of just like the School of Computing. That's all right. You can go ahead and come back, fix your mistakes, and hand it back in. And you'll see that you've earned those 15 points back now. Some assignments are going to require that you have exact output. Some assignments are going to allow you a bit of freedom on your formatting. Some assignments are going to just run thousands or even millions of test cases automatically in the background, and it'll award you the points based on whether or not they all pass or they all fail. You really need to be looking at the test results to understand what you have missed, or if everything was working correctly, or if it even compiles. Labs are generally based on completion, so you'll see that we've already earned those 15 points. You'll be able to see any comments from graders on actual hacks once they've been published. Make sure that you're using this tool to its fullest, that you're addressing any and all issues with your code before the actual due date.